Hi, everyone. My name is Kevin Sapp. I'm the CTO and co-founder at Aembit. Today, I'm going to talk about human out of the loop, the gaps and pitfalls and promises of identity for agentic AI. The agenda for the talk is what are AI agents and why they matter, identity challenges in agentic AI, how to secure autonomous systems, and then we'll follow up with takeaways and forward-looking principles. So I think it's good to start with a little bit of background around agentic AI. So I want to talk about four key milestones. So about the middle of 2020, we saw the rise of transformers and general purpose LLMs. The most famous or notable of which is GPT-3. That's when these systems really demonstrated flexible reasoning across domains. In 2022, we saw the emergence of prompt engineering and tool use using techniques like React and LangChain, popularized by multi-step reasoning with external tool calls. Now, later in the presentation, I'll talk a little bit about tools and what we mean by that. In 2023, we saw early agent frameworks and hosted agents. So these were software frameworks or application frameworks for building primitive AI agents that were orchestrating LLMs and then the tools that they interact with. And fast forward to today, and in 2025, we're now seeing some standardization happening in terms of how AI agents are built and how the components of AI agents communicate with each other. And we're also starting to see some secure identity patterns emerge. So things like workload identity best practices and the model context protocol, both of which I'll talk about pretty extensively throughout the deck. So the first thing I would say, particularly to people that are not software developers, is that AI agents seem magical. That's pretty obvious, but from my perspective, they're not. They're not magical. They are very powerful pieces of software and very much a leap forward in terms of technology. But ultimately, AI agents are software systems. They're built by developers and they tend to be orchestrated in the cloud. So they're new types of software and they're built in newer environments, and not typically data centers and so forth. There's not a lot of legacy AI agents running around. AI agents use large language models or LLMs to reason and tools to act. So this is important, and I'll illustrate this later with some figures. But this notion of reasoning and the notion of taking action is really what makes an AI agent. And for the people listening to this talk, understanding the architecture of AI agents is essential to securing them. I don't think you can really apply security patterns if you don't understand the fundamental software architecture. And the idea that they seem to be clouded in mystery is what's creating a lot of FUD, really, fear, uncertainty, and doubt in the security industry. So here we're going to get a good overview of how these systems are architected and constructed, and hopefully that'll help everyone with some takeaways in terms of how to approach security. So first off, what is an AI agent? AI agents are software systems that use LLMs to reason and act autonomously. They execute dynamic, multi-step tasks across APIs and tools. This last phrase is really important, and I think that's the essence of an AI agent, is that they are dynamic and they can both plan and execute multi-step tasks. Agents are composed of multiple software components. They're not monolithic. They're built with cloud native infrastructure typically, and they're designed to operate autonomously. AI agents may have a user interface, and there may be ways for people to interact with them, but for the most part, they're meant to operate autonomously and perform jobs, essentially. So let's look at the anatomy of an AI agent, kind of the core components. There's a lot of terminology floating around about AI agents. It's evolving very rapidly in terms of not only architectures, but just the way people think about AI agents. But I'll describe kind of these high level parts and using this terminology, and then we'll apply some of that to some more standardized terminology later. But first, there's really an orchestrator That's the central component or the control plane of the AI agent. And its job is to maintain memory or state and coordinate execution. By state, that's really the context essentially under which the AI agent operates. This might be prompts from a user, it might be data from a database or what have you, but all of that information is held in memory by the orchestrator. Then there's a reasoning engine. That's really the LLM. So the LLM is going to determine actions based on goals that are provided to it, either pre-provided or again provided by a user, context, and then it will make a plan. The next part of an AI agent is tools or connectors. Really, tools are the APIs or services that AI agents connect to for context, for data, or to perform some action. So think about collaboration tools like Slack, Teams, etc. It could be databases, cloud storage. And then finally, we need to consider the environment in which these AI agents operate, the workload runtime where each component executes, like virtual machines, containers, or serverless functions. So if we look at a more standardized approach, we need to consider the model context protocol. And by the way, I would encourage all the viewers to go out and look this up if you're unfamiliar with model context protocol. It's evolving pretty rapidly, but it's standardizing a lot of the architectural, especially the communication parts of agentic AI. In this example, the MCP host, like LibreChat, you can find open source tools that are sort of pre-built MCP hosts, act as the agent's orchestrator. They call both LLMs for reasoning, and then they call various tools via what are known as MCP servers. MCP servers expose real services. In this case, I'm showing the Microsoft Graph API as modular building blocks the agent can use. This architecture separates orchestration, reasoning, and execution, each needing its own identity and trust model. So, what are the challenges with agentic AI from a security perspective? I think the first challenge, both intellectually and from a security perspective, is around identity ambiguity. So, when you have an AI agent and it connects to an external service, like the Graph API or Stripe or what have you, who is the actor? Is it the user that's using the AI software? Is it the orchestrator who's responsible for coordinating various activities? Or is it the tool, for example, the MCP server we showed in the previous diagram, which is the actual part of the AI agent that actually connects to the service? Traditional identity and access management solutions really lack a layered identity model. If you think about your SSO provider that you log into at work every day, it really is aware of two entity types. One is a person, a user, and then two is the applications that user wants to connect to. So, for example, I'm a user. I may want to log into Salesforce. I use my IAM system for that, and that flow is pretty straightforward. It's just me, one principal accessing one service. But with an agentic AI system, which actually has multiple subcomponents, each with its own identity, you actually need to consider all of those identities as a composition. And our IAM systems today don't really account for that. And this ambiguity undermines fundamental security principles like the ability to audit what's going on, compliance with regulatory rules, and least privilege access to these services. The second big challenge, I think, is around secret sprawl and over-permissioning. So credentials are often hard-coded in configuration files or environment variables. Now, this is a common problem with distributed software systems anyway, but I think we'll end up seeing this quite a bit with these AI agents, because even in the simplest construction, like what I showed in my diagram, you still have 3 or 4 different subcomponents that all need to connect to each other and need to connect to other services. And it's just easier, if you will, to do it this way. Developers will over permission components just to make it work. And, it's a lot easier to just say, hey, this component has access to everything, all of the data in the database, for example. And you're not going to spend a lot of time troubleshooting issues that might be related to incorrectly configured permissions. So this is something we really have to be mindful of and watch out for. A single secret might unlock multiple tools And that is very high risk if that single secret is compromised. So, for example, people may use a similar API key across multiple components to access various types of tools, or they might use a similar username and password, for example, if it's a database. This is generally a bad idea. It's generally bad practice. But again, I think that we will see this type of scenario when people are building and deploying these AI agents, just because the complexity in the overall architecture. Even in well-groomed environments where you might be using something like a secrets vault to store credentials, you still need a way to unseal the vault. And usually what that means is you end up with a fundamental secret that is very, very sensitive, because that unlocks the vault, and then you get access to all of the other credentials that could be used by attackers. So when we think about AI agents, for me, one of the big takeaways is that every component needs its own identity. Each agent component is a standalone workload, and it must be independently authenticated. So again, we talked about the orchestrator, we talked about connectors, we talked about tools, etc. All of these things need to be authenticated with their own identity. And when we do that, that enables scoped, least privileged access. It enables trust enforcement at runtime and a causal chain for audit and for forensics. So again, if the AI agent were just a single entity, and you would say, okay, well, this agent is accessing a particular service, then I would know sort of the cause and effect relationship. But when you really have multiple components that are being orchestrated and working together, understanding the chain really from the user to the AI agent's interface to the call to the LLM and then off to multiple tools, you need to be able to stitch that chain together in some fashion in your logging system. So there's a lot of talk right now about OAuth 2.1, PKCE, and the MCP authorization specification. In fact, I think it's a very important document, and I provide a link to it here. It's open source, it's available. This is Anthropic basically started this specification. It has lots of contributors from around the world. And it's a very good specification for how to handle delegated authorization. So really what the spec provides is user to agent delegation, and it solves for delegated access, really using traditional OAuth patterns primarily. But what it doesn't do, and what it doesn't intend to do is address the identity of the agent itself. So, it doesn't even talk about how you authenticate an agent or components of an agent in the first place, such that they can get access to these services and so forth. It really just talks about token issuance, and that's appropriate, right? It's a separation of concerns. But as these agents become more autonomous, we need to think about identity solutions to cover authenticating the non-human actors, and we need to consider the runtime conditions of the AI agent itself. Just some advice or a way to think about all of this is, first, I think you should authenticate workloads like you authenticate people. And I don't mean by using the same mechanisms by which you authenticate people. I just meant you should authenticate workloads with the same rigor you apply to authenticating people. The mechanisms will be different. So some of the mechanisms for authenticating workloads is, first, we need to use cryptographically verifiable identities to authenticate each workload. We need to utilize workload identity federation everywhere it's supported. So all of the major cloud providers support this today, but many SaaS providers, for example, do not. Again, the perfect is the enemy of the good, and we should utilize advanced authentication where we can, and we need to gracefully degrade to support the real world where we can't do identity federation. We should apply conditional access policies. So you need to consider things like location. For example, what region is your AI agent software deployed in? Time of day. Are there any constraints around time of when the agent should operate or be able to do certain actions? And maybe most importantly is the security posture of the runtime on which the agent is running. And so we, of course, want to prevent malware in those types of situations. And it's not enough to simply authenticate the components of the workload. You also want to ensure that they're secure. And then lastly, you should strive to issue short-lived credentials for access to tools wherever possible. It's not possible in all cases. For example, in the diagram that I showed, where the AI agent actually wants to connect to the Anthropic API, to use, for example, Claude, they only support API keys, which API keys are, they are long-lived sort of static credentials. So there are certainly some cases where you can't apply short-lived credentials, but in many other cases you can. So many SaaS services support short-lived credentials through token exchange and so forth. So you should always strive for short-lived credentials wherever you can. That way, if the credential is compromised, it can only be utilized by an attacker for a very limited amount of time. The next big bit of advice is to observe and audit everything. So you want to log every access and identity assertion in a central location. You want to maintain traceability from the user goal to the agent action to resulting in an actual API call to a service. And once you have this logging in place and it's centralized, you can utilize this information for trust, compliance, and incident response. So, for example, if there were a security incident or a breach, you would be able to understand what happened and potentially stop that. Implementing observability right from the beginning, I think, is critical. Okay, some final takeaways. AI agents are modular systems. They're not monoliths. I think this is very important for all of us to understand. I made this point throughout the deck, but that should be one of the big takeaways. It's not one piece of software. It's really composed of multiple pieces of software working together. The autonomy of AI agents introduces new identity and security challenges. So your existing identity tooling is probably not going to work very well when applied to this particular problem. So you need to look at it from a fresh perspective. You should secure your AI agents by treating each component of the agent system as a first-class identity-aware workload. And then lastly, identity, context, and observability need to all work together. We provide these identities to these subcomponents. We understand the context in which they operate, and then we continually observe and monitor them. So the big takeaway is that agentic AI is a greenfield opportunity for cloud and just general cybersecurity practitioners to get non-human identity right from the beginning. Like I said, you don't have a lot of legacy AI agents in your environment running around in your data center, et cetera. You will have developers building these systems very rapidly. I think most large enterprises will see lots and lots of software built using agentic AI patterns. So I really encourage everyone in security to understand these architectures and get involved very early, right at the beginning of the development process. So again, my name is Kevin Sapp. I'm the CTO and co-founder at Aembit. You can reach me at kevin@ambit.io or find me on LinkedIn at /KevinSapp. I'm happy to talk about agentic AI all day long and the security issues therein. So look forward to hearing from you.